name is Steven Stevenson. I'm a new professor in the Department of Chemistry at IPFW. I just moved here about a year and a half ago, and the research that I do upstairs is very exciting to me. It's arguably the love of my life, with the exception of my wife, of course. Basically, what my research is, it's new molecule chasing. And we've heard of storm chasers that chase tornadoes, right? So what I do is I chase new molecules. So basically, how do you make new molecules? How do you know if you have a new molecule? And once you make a new molecule, what do you do with it? How do you separate it away from all the other molecules that are known to exist? And then once you've finished that hurdle, then you collaborate with other scientists who have the instrumentation and equipment to find applications and characterize your new molecule. I've been doing new molecule chasing for probably about 18 years, and I still love it just as much as I have before. But basically, the type of research that we do for new molecules is we need to have a source of all the chemicals, and we need to have some reaction vessel to make the new molecules in. And sometimes in nature, we need a little boost to get things to react, get over their activation energies. So the hotter the better, I say. So we have built a new molecule reactor, so to speak. And in this new molecule reactor, we're able to achieve temperatures 6,000, 7,000 degrees. So we get the chemicals really hot, and we see what happens. The first molecule that we reported or published just a couple of years ago had 4 metal atoms and 2 oxygen atoms. So at the time it had set a world record. 6 atoms trapped inside of this hollow cage. So you say, well, okay. In 1999 we had 4 metal atoms, or 4 atoms. A couple of years ago we had 6 atoms. Can we try for 7 atoms? So we published that paper shortly thereafter, with 4 metal atoms and 3 oxygen. So far, 7 atoms in a cage is a world record. So we are making these molecules upstairs at IPFW here at Indiana Purdue University at Fort Wayne. We also just published a paper with 2 metal atoms and an oxygen atom with a slightly larger cage. So in my group, I have about half of my research in the area of new molecule synthesis, how to make new molecules. I have several students working in that area. Another half of my research group, they are students working in separation science. So what do I mean by separations of new molecules? Well, in this reactor we make at least 50 different kinds of compounds. This is maybe one of 50 types of compounds. Most of the molecules that we make have been discovered already. So we have to sort or separate the new molecules from the well-known molecules. So how do we go about doing that? Because about 40 of these different types of molecules are hollow. So we have large buckyballs and small buckyballs, empty buckyballs, buckyballs with metals but no nitrogen, buckyballs with metals and oxygen, buckyballs with different amounts of metals and oxygens and nitrogen. So we have about 50 different kinds of compounds. So how do you get the one that you want plucked out of a potpourri or out of a mixture of molecules? So that's what the other half of the Stevenson research group is working on. And without going into any detail there, we are currently publishing some work that our IPFW students have done. So whoever's listening, if you're interested in doing some research with Professor Stevenson, you can look me up online in the chemistry department and find me, and you can have all the contact information there. So in the future, where we're going is pushing the envelope to different kinds of additives, and just doing some good research. And what do we do with the good research? What opportunities do IPFW students have? Well, in addition to the fun, working on the research end. We also have fun as a group and traveling and presenting our data and presenting our findings. And we do really good work in the Stevenson lab. I have to brag about my students. Several of my students have won first place awards for best presentation, best talk. So the combination of good, solid research plus the opportunity for students to present their findings and put that on applications to medical school, applications for graduate school, that helps their resume for whatever career path that they choose. Well, I'm very happy to wake up one day, come into work, and check my email. And sometimes good things happen when you check your email. And we just found out that our new molecule and an illustration of the new molecule in the research was the cover picture for this Journal of the American Chemical Society. So for those of you that are geeks like me, what is the Journal of the American Chemical Society? Well, every week the nation's, arguably one of the nation's most significant journals for chemists will have maybe 30 or 40 articles in it, and then from those 30 or 40 articles they'll pick out a particular article and say, you know what, I would like to have that picture on the cover. So then they invite artists to compete for a spot. And I didn't do this diagram, one of our collaborators did. We had collaborators in Germany, and Alexei Popov, he did the artwork, submitted it, and it was selected. So now I can retire, now that our molecule's been selected for the cover page of a magazine. So looking closely at the magazine, you can see this structure of 4 metal atoms and 2 oxygen atoms. Now subsequently we have 3 oxygen atoms and 4 metal atoms. So here at IPFW we have the largest number of atoms in a cluster trapped inside one of these carbon cages. So IPFW world record holder. Most atoms crammed in a cage. So this relates to my research here at IPFW because we have discovered yet more new molecules that have oxygens and metals in them. And so my students are going to be spending, like it or not, they're going to be spending a lot of time in the lab, which of course they're going to like. We have some new yttrium oxide molecules, some lutetium oxide molecules, and erbium oxide molecules. So we figured out a way upstairs in our plasma reactor to combine in nature at 7,000 degrees new combinations of metals and oxygens. Now to some people that might be boring, but all this excitement is corroborated by the selection of our cover page. So we're constantly discovering new molecules. And so this hopefully is just the beginning of the mastodon tidal wave of geekness.